Welcome to week 4 of our IGCSE Chemistry revision course. This week we'll study the atmosphere and pollution, then examine carbonates and their reaction, and finally explore organic chemistry, one of the most fascinating areas, linking everyday fuels, plastics, and biological molecules. Air is mostly nitrogen and oxygen, with trace gases like carbon dioxide and argon. Experiments with phosphorus or iron filings burning in air show that about one-fifth of air is oxygen. These simple practicals demonstrate how oxygen supports combustion and are often tested in short answer questions. Pollution gases have serious effects. Carbon monoxide binds to hemoglobin, reducing oxygen transport. Sulfur dioxide and nitrogen oxides dissolve in rainwater to form acids, damaging plants and buildings. Catalytic converters in cars convert CO to CO2 and NOx to nitrogen, greatly reducing harmful emissions. The greenhouse effect is natural and vital, but excess greenhouse gases cause global warming. Deforestation and fossil fuel use increase CO2 and methane levels. This traps more heat, raising global temperatures. Mitigation techniques include reforestation, renewable energy, and energy efficiency, all mentioned in environmental chemistry exam questions. Carbonates are common salts of carbonic acid. They fizz with acids, releasing CO2, which turns lime water cloudy, a standard gas test. When heated, most metal carbonates decompose. Calcium carbonates form quicklime, used in the lime cycle. And remember, carbonates of group 1 metals do not decompose easily. The lime cycle connects calcium carbonate, oxide, and hydroxide. Heating limestone forms quicklime, slaking it with water makes slaked lime, and exposure to CO2 reforms limestone. This process is important in cement and agriculture and is a great example of reversible reactions in everyday chemistry. Organic chemistry focuses on carbon's unique ability to form long chains and complex molecules. Hydrocarbons, made of carbon and hydrogen, come from crude oil. Fractional distillation separates this crude oil into useful fractions like petrol and diesel based on boiling points, forming the starting materials for many organic reactions. Alkanes like methane and ethane are stable and burn cleanly in oxygen. Alkenes like ethene contain a double bond between the carbon atoms, making them more reactive. The bromine water test distinguishes them. Alkenes decolorize orange bromine water, while alkanes do not. This test is commonly asked in exams. Ethanol is the simplest alcohol used in fuels and solvents. Ethanoic acid is the main carboxylic acid used in vinegar. When they react together, they form esters, which have pleasant fruity smells. These reactions link functional groups, an important idea for identifying organic families in exams. Polymers are long chains made from smaller monomers. Addition polymers come from alkenes, like ethene, forming polyethylene. Condensation polymers form by linking monomers with functional groups, releasing small molecules. Plastics are versatile but hard to decompose, creating pollution issues. Recycling and biodegradable materials are important solutions to this issue. To recap, we studied how air supports life but can be polluted, how carbonates react and cycle between compounds, and how organic chemistry explains fuels, acids, alcohols, and plastics. Together, these topics highlight chemistry's environmental and industrial importance, connecting everything from climate to materials. Thank you.